go.
And we're off. So okay, everyone hear me? Okay. So we're talking about cancer. Everyone knows somebody who has cancer, and we're specifically trying to address the problem of how to improve it. Fundamentally, there's a huge problem in the world today where people get a lot of unnecessary treatments and invasive biopsies at great pain and great economic expense to the healthcare system. What we're about is trying to take a single cell or a series of single cells out of the bloodstream to get you a circulating tumor cell which represents the genomic content of the cancer. And we believe firmly that it'll provide deep insights on how to treat and how to manage patients for better outcomes. Our approach, candidly, we believe it's absolutely the best approach out there. The market is massive. It's about, recent estimates have put it around $29 billion at maturity. What we do is we have this thing called a bump array or a Plachenko, if you remember how coins get sorted. And this is a patented micropost technology that's now been reduced to a plastic consumable. And it efficiently allows blood to process through, red cells disappear, leaving the white cells. And what we do is we then take the white cells and remove those magnetically, leaving us with a pool of tumor cells. Our solution delivers a very easy to use and there's a robust approach. We have cancer cells coming out the bottom end of our process that are inclusive of all the candidate cells. It doesn't select on the basis of size, which a lot of techniques out there are trying to do. It doesn't damage the cells. They're very alive and viable. And they're not touched by any antibodies or any other affinity reagents. So they're truly a naive cancer cell ready for a molecular analysis. And this is ultimately going to be dispensed so that they're ready for automated clinical processes. This allows customers, such as clinical labs, reference labs, and clinicians themselves to order up a wide range of molecular analysis, but also, more importantly, to do functional assays on the cancers to really see if the drugs are actually responding. It's great to have a molecular signature, but that just gives you something that's been reported in the literature. It doesn't necessarily tell you if that patient's going to actually respond. And in addition, classical imaging, FISH, and where did the cell come from? Is it have PSA? Well, then it's going to be prostate-specific cancer. So the team, more importantly, is a significant team. I have Kurt Sibbin, who found the CD34 stem cell antigen on our board. We have Dieter Rechtenwald, who's got 20 years at Becton Dickinson and elsewhere. Jim Sturm from Princeton. We have Mike Grisham, who founded Artemis Health and sold part of an application using this technology to Illumina for $350 million. Lee was a CFO at CellPoint Diagnostics and Aetna. Myself, I used to run eBiosciences before it was acquired by Affymetrix, and since that have departed to head this initiative up for GPB. We have Khushru Gandhi, and in the audience we have Roberto Campos. Khushru comes to us from Life Sciences, from Caliper Technologies, and Roberto comes to us from CST. So we have the team, and we have the skill. What we're looking for is some money.
All right, perfect ending on 3 minutes. Terrific, thank you.